Hi everyone, we're going to cover our last group of basic trig identities, the Pythagorean identities. Last but not least. In fact, I'd say they're probably the third most important group. The most important group, I'd say, are the reciprocal identities, then quotient, then these guys, the Pythagoreans, then even odd, those help in calculus, for example, and then cofunction you'll see once in a while, but those are probably at the bottom. Those are probably the least. But the Pythagoreans, they're pretty important, and we'll deal with those right now. Know these three, or at the very least, memorize this basic Pythagorean identity and figure out the other two. All right, let's start by basically showing this first one and why it's true. The Pythagorean identities. All right, so let's consider the unit circle. Radius 1, that's the hypotenuse of this right triangle. Assume for now theta is acute. Okay, now remember that in order for SOHCAHTOA to work, this side has to be sine of theta. In other quadrants, it could be negative as a signed length. This side here has to be cosine of theta. The x-coordinate of this point is cosine of theta. The y-coordinate of this intersection point is sine of theta. All right, look at this right triangle. The square of the hypotenuse equals the sum of the squares of the other two sides, the legs. The square of sine of theta plus the square of cosine of theta equals the square of 1. The square of sine of theta we denote as sine squared of theta. Move this up here. The square of cosine of theta is cosine squared of theta. The square of 1 is 1. So here's the basic Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. It comes from the Pythagorean theorem. Now, even though it's hard to draw a right triangle for quadrantal angles, still, this holds for quadrantal angles theta and even for other quadrants. Symmetry helps. This is the basic Pythagorean identity. But there are two other identities in this category. Oh, but by the way, you can manipulate this as well. So, for example, we can also say that, sine squared of theta is equal to, we can subtract cosine squared theta from both sides. This equals 1 minus cosine squared of theta. Sine squared of theta equals 1 minus cosine squared of theta. And similarly, cosine squared theta is 1 minus sine squared theta. Now, although those are different identities technically, still, if I ask you to write down the three Pythagorean identities, I think these are too closely related. If I ask for the three Pythagorean identities, I want this one, and I want the other two over here. Basically, I want one identity like this, one identity like that, one identity like that. So when you list the three Pythagorean identities, I want to see the squares of all 6 trig functions. But make sure that they're correct. They're easy to mess up. So how can we get from this first one to the other two? Well, one thing we can do is divide both sides by sine squared of theta. Don't worry about domain right now. We'll deal with that later. Let's take both sides, all terms on both sides, divide by sine squared theta. Sine squared theta over sine squared theta is 1. Plus cosine squared theta over sine squared theta is cotangent squared theta. That does work. 1 over sine squared theta is cosecant squared theta. So dividing both sides by sine squared theta, we get this second Pythagorean identity. And again, there are variations, but I'm not going to really call those different identities. They technically are, but I'm not going to really call those different identities. This is basically our second Pythagorean identity. Guess what? To get our third Pythagorean identity, we're going to take this original Big Daddy Pythagorean identity and divide both sides, that is all these terms, by cosine squared of theta. Sine squared theta over cosine squared theta is tangent squared theta, plus cosine squared theta over cosine squared theta itself is 1, equals the reciprocal of cosine squared theta is secant squared theta. And here's our third Pythagorean identity. Tangent squared theta plus 1 equals secant squared theta. Okay, as it turns out, cosecant of theta and secant of theta are going to have the weirdest graphs. So you could think that the squares of the weird graph guys are all alone on one side. And the tangent or cotangent squared guys are together with the ones. It's easy to mess these up. When in doubt, derive these from the basic identity. So that takes us to our fifth and final group of basic Pythagorean identities. We'll have many more in chapter 5, actually, but we've done now our 5 groups of basic trig identities. Again, reciprocal first, quotient, and then in order, we did cofunction next as a third group, then even odd as our fourth group, and then Pythagorean as our fifth group. Although again, in terms of relating their importance, reciprocal identities tend to be the most common and most important, then quotient, then these Pythagorean identities, then even odd, then cofunction. That's my opinion. But know all of these, love all of them, and be prepared to use all of them. All right, now finishing up the 4.2 to 4.4 block, we're going to save inverse trig functions for 4.7. I'll come back to this later when we cover 4.7, if you don't mind. And then word problems, if you don't mind, we'll postpone those till 4.8. So yay. I say for now we're done with the 4.2 to 4.4 block. We'll deal with these other issues later on. Thank you very much. Next up, how do you graph trig functions? Next time.